Section 10 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by M.L. Cohen, Cleveland, Ohio, March 2007. Familiar Letters on Chemistry by Justus Liebig, Letter 10. My dear Sir, let me now apply the principles announced in the preceding letters to the circumstances of our own species. Man, when confined to animal food, requires for his support and nourishment extensive sources of food, even more widely extended than the lion and tiger, because, when he has the opportunity, he kills without eating. A nation of hunters, on a limited space, is utterly incapable of increasing its numbers beyond a certain point, which is soon attained. The carbon necessary for respiration must be obtained from the animals, of which only a limited number can live on the space supposed. These animals collect from plants the constituents of their organs and of their blood, and yield them in turn to the savages who live by the chase alone. They again receive this food unaccompanied by those compounds destitute of nitrogen which, during the life of the animals, serve to support the respiratory process. In such men, confined to an animal diet, it is the carbon of the flesh and of the blood which must take the place of starch and sugar. But 15 pounds of flesh contains no more carbon than 4 pounds of starch. And while the savage with one animal and an equal weight of starch should maintain life and health for a certain number of days, he would be compelled, if confined to flesh alone, in order to procure the carbon necessary for respiration, during the same time to consume 5 such animals. It is easy to see from these considerations how close the connection is between agriculture and the multiplication of the human species. The cultivation of our crops has ultimately no other object than the production of a maximum of those substances which are adapted for assimilation and respiration in the smallest possible space. Grain and other nutritious vegetables yield us, not only in starch, sugar, and gum, the carbon which protects our organs from the action of oxygen, and produces in the organism the heat which is essential to life, but also in the form of vegetable fiber, albumin, and casein, our blood, from which the other parts of our body are developed. Man, when confined to animal food, respires like the carnivora at the expense of the matters produced by the metamorphosis of organized tissues, and, just like the lion, tiger, hyena, in the cases of a menagerie, are compelled to accelerate the waste of the organized tissues by incessant motion, in order to furnish the matter necessary for respiration. So the savage, for the very same object, is forced to make the most laborious exertions and go through a vast amount of muscular exercise. He is compelled to consume force merely in order to supply matter for respiration. Cultivation is the economy of force. Science teaches us the simplest means of obtaining the greatest effort with the smallest expenditure of power, and with given means to produce a maximum of force. The unprofitable exertion of power, the waste of force in agriculture, in other branches of industry, in science, or in social economy, is characteristic of the savage state, or of the want of knowledge. In accordance with what I have already stated, you will perceive that the substances of which the food of man is composed may be divided into 2 classes, into nitrogenized and non-nitrogenized. The former are capable of conversion into blood, the latter are incapable of this transformation. Out of those substances which are adapted to the formation of blood are formed all the organized tissues. The other class of substances, in the normal state of health, serve to support the process of respiration. The former may be called the plastic elements of nutrition, the latter, elements of respiration. Among the former we reckon vegetable fibrin, vegetable albumin, vegetable casein, animal flesh, animal blood. Among the elements of respiration in our food are fat, pectin, starch, basarine, gum, wine, cane sugar, beer, grape sugar, spirits, sugar of milk. The most recent and exact researches have established as a universal fact, to which nothing yet known is opposed, that the nitrogenized constituents of vegetable food have a composition identical with that of the constituents of the blood. No nitrogenized compound, the composition of which differs from that of fibrin, albumin, and casein, is capable of supporting the vital process in animals. The animal organism unquestionably possesses the power of forming, from the constituents of its blood, the substances of its membranes and cellular tissue, of the nerves and brain, and of the organic part of cartilage and bones. But the blood must be supplied to it perfect in everything but its form, that is, in its chemical composition. If this be not done, a period is rapidly put to the formation of blood, and consequently to life. This consideration enables us easily to explain how it happens that the tissues yielding gelatin or chondrine, as for example the gelatin of skin or of bones, are not adapted for the support of the vital process, for their composition is different from that of fibrin or albumin. It is obvious that this means nothing more than that those parts of the animal organism which form the blood do not possess the power of effecting a transformation in the arrangement of the elements of gelatin, or of those tissues which contain it. The gelatinous tissues, the gelatin of the bones, the membranes, the cells of the skin suffer in the animal body, under the influence of oxygen and moisture, a progressive alteration. A part of these tissues is separated, and must be restored from the blood. But this alteration and restoration are obviously confined within very narrow limits. While, in the body of a starving or sick individual, the fat disappears and the muscular tissue takes once more the form of blood, we find that the tendons and membranes retain their natural condition, and the limbs of the dead body their connections, which depend on the gelatinous tissues. On the other hand, we see that the gelatin of bones devoured by a dog entirely disappears, while only the bone earth is found in his excrements. The same is true of man, when fed on food rich in gelatin, as for example strong soup. The gelatin is not to be found either in the urine or in the feces, and consequently must have undergone a change and must have served some purpose in the animal economy. It is clear that the gelatin must be expelled from the body in a form different from that in which it was introduced as food. When we consider the transformation of the albumin of the blood into a part of an organ composed of fibrin, the identity and composition of the two substances renders the change easily conceivable. Indeed, we find the change of a dissolved substance in an insoluble organ of vitality, chemically speaking, natural and easily explained, on account of this very identity of composition. Hence, the opinion is not unworthy of closer investigation, that gelatin, when taken in the dissolved state, is again converted in the body into cellular tissue, membrane, and cartilage, that it may serve for reproduction of such parts of these tissues as have been wasted, and for their growth. And when the powers of nutrition in the whole body are affected by a change of the health, then, even should the power of forming blood remain the same, the organic force by which the constituents of the blood are transformed into cellular tissue and membranes must necessarily be enfeebled by sickness. In the sick man, the intensity of the vital force, its power to produce metamorphoses, must be diminished as well in the stomach as in all other parts of the body. In this condition, the uniform experience of practical physicians shows that gelatinous matters in a dissolved state exercise a most decided influence on the state of the health. Given in a form adapted for assimilation, they serve to husband the vital force, just as may be done, in the case of the stomach, by due preparation of the food in general. Brittleness in the bones of graminivorous animals is clearly owing to a weakness in those parts of the organism whose function it is to convert the constituents of the blood into cellular tissue and membrane. And if we can trust to the reports of the physicians who have resided in the East, the Turkish women, in their diet of rice and in the frequent use of enemata of strong soup, have united the conditions necessary for the formation both of cellular tissue and of fat. End of section 10. Recording by M.L. Cohen, Cleveland, Ohio, March 2007.